Welcome everyone to this week's IPLD sync meeting. It's September 28th, 2020, and as every week we go over the stuff that we've done in the last week and plan to do and discuss any other items that someone might have. So I start with myself. Again, news from the Rust side of things. So the major Rust multi-hash thing that I was talking about in the past few weeks finally got merged. It was kind of a big refactor, is now kind of back to what it originally was on the first refactor. And but in the end, so now if you want to integrate it into the current Rust CID, it's really nice because it's really just really small changes, which is, I think, a good sign that, yeah, I got things correct. So this brings us a bit closer to merging an upstream into Rust multihash. And what I currently worked on today was, although this refactor landed, now everything is stack allocated. And what you need to do is, if you define your own code table with hashes, you need to define how big actually the stack allocation is. And we decided that we make it explicit, so you really have to set some value, but it could still be that you use a hasher which produces a bigger digit. And currently then your stuff will just panic. And the plan is to have better error reporting saying on compile time, hey, one of your hashes would want to allocate more than you have specified, so you might want to increase it. The reason why we don't do it automatically is that all this, sadly, in Rust is working without types, so it's purely on syntax, which is a bit scary. But I expect that people just, if they use it the normal way, everything will be fine, and they don't even notice that it's only a syntax thing and not a type thing. Yeah, at least it should get smooth things out for people implementing things. And the other thing that needs to happen before we can merge into upstream Rust multihash is Blake 3 support. That finally got kicked off by a community member, and so I'm only doing the reviews, but it's slowly getting there. Yeah. Other things is that next I look into some WASM stuff. I will get into more detail about this next week, I guess, when I know more. Next on my list is Danielle.
Cool. So I continued with Hempt. I spent quite a bit of time trying to update the schema and the code generation with Rod's schema in the hash map document. So that's done now. We also discussed a bunch of ways that we could simplify the schema, which were mostly things that Rod already had in mind, but which could be nice to just finish up before I write a lot more code. And getting some agreement on those was also nice. I also got nerd sniped into looking into a JSON panic that Lotus got a week ago or so. And it turns out, like, I was very confused by this because I started looking into it around Wednesday last week. Initially, I thought it was just a JSON package bug, but I was digging more into it today. And it's gotten to the point where I think there's a language bug somewhere because methods are not being promoted consistently, which is pretty scary because the Lotus project is hiding one method and replacing it with another method, but then that's just not working. The replacement is not working as expected. So I filed a spec bug if anyone wants to look at that. I also helped with the reviews on Go Merkle DAG. So I think I follow most of what Rod is doing there. So hopefully my review is helpful. And finally, it seems like everybody is okay with me adopting the Go multi-codec repo and just replacing it with a bunch of code-generated Go constants. So I'll do that soonish now that I've got sort of like the okay from everybody. And that's it.
Thanks. Next is Eric.
So I was kind of all over the place this week, answering a lot of questions. I'm sort of building up a backlog of things that I now have discovered we do need a little bit more API documentation on, especially, as well as our usual need for docs. The little review of the DAG-PB stuff that Rob's working on, and I'm really glad that he's working on that. I had to do some work in the Go IPLD repos this week to start adding resource budgets to codecs. This is because we want these things to be resistant to denial of service attacks, even in the case of fairly maliciously formed inputs. So we started getting some fuzzing in on things, and it is discovering things where we need to sanity check more values, make sure allocations are reasonably bounded and stuff like this. So I've started some PRs that do keep running budgets even, and so that's pretty exciting. Getting those things to be totally consistent is interesting, but at this point there's some accounting that's reasonably consistent and some other things that are willing to let you like run ahead of the budget by a fixed amount, and I think this will in total pretty much end up okay. It could be more pure, but should do. I've been doing a little work this week with Will on describing some more of the Filecoin systems using IPLD and IPLD schemas via his project, which is the StateDiff project. And that is being really darn exciting. I don't know if he'll want to chime in more with this, but basically it's generating a lot of experience points and will probably continue to do so. We're finding that we can describe a lot of Filecoin structures, unsurprisingly, with IPLD schemas, because a lot of them were originally drafted in the same headspace as the schema language, so like it stands to reason. A couple of things have evolved in interesting ways that are a little bit trickier to describe, and a couple of things just fall in the corners of parts of the schema cogen system that I haven't implemented yet because they're the less frequently used features. So getting lots of to-do lists out of that. We've had some really interesting reflections on how developers might want to make custom codecs sometimes. There are a couple of interesting little spinny bits in Filecoin where they have the serialization, which is the binary protocol. Like it has a certain specified structure. It's going to be encoded in DAG-CBOR. All of the hashing for the trees is DAG-CBOR. So like that's clearly the way that the thing is serialized. But then part of the goal of the StateDiff project that Will's working on is have human readable presentations of these things so that we can like create visual diffs. And most of the time it is perfectly reasonable to just swap the codec, the multi-codec. That's kind of the point of them. So you just like stop using DAG-CBOR, start using DAG-JSON instead. And then you get reasonably diffable stuff. There's a couple of cases where the Filecoin project had already made some other choices where some structures are supposed to be JSONed in a custom way, and this is not generally how we would suggest a project do this if it's doing new work in the IPLD universe, because it's
maybe even the opposite way, which is you've got things that have a string representation that is what you would use, for instance, because they're used as map keys everywhere. And in JSON, you need strings as your map keys. And so that's what you would expect. But in CBOR, you can use a bytes, much more compact representation. And so they do. And so are we going to say that this is bytes based on the CBOR encoding, which is our canonical encoding? But then if I want a JSON, I probably want the string and not non-printable Unicode map keys. So saying that, you know, we have the same underlying data, but with sort of a string representation, which is probably the best you're going to do in JSON, and a more compact binary representation when you're going to CBOR, is not something that fits super nicely.
Yeah. I was mostly thinking about the weird shenanigans going on with the address field, which seem to require custom. But there's also, we're also looking at the byte keys in maps situation again. And
addresses get used, and the keys in maps everywhere. And it's that same thing.
Yep. And so then figuring out how to pretty print those is like, oof. It's just unclear what should be done there. And the usual, just replace CBOR with JSON codec. It doesn't feel great. It works, but it doesn't. Anyway, so we'll have more to report on that in the future, I hope. Yeah, that's all I'll say about that. I wrote a new document recently about map ordering, a piece of our docs and specifications for the whole project that we really need to nail down. I've launched this as a GIST, so there's a link in the group chat here, or in the document that we'll post into the team repo later. I want to mention briefly that I'm posting this as a GIST again, and I'm doing this because I'm finding it to be an effective way to get things done, but I want to also introspect on that out loud for a moment because I'm not thrilled about the fact I'm finding that a good way to get things done. We really need to hammer out a way for landing stuff reliably. I'm publishing stuff as GISTs because it's hard for me to lose track of them and easy for me to link them. And I hope that I'm able to take GISTs and ram them through review limbo in some fashion later. But we need to develop a process for landing doc stuff at a consistent pace with some sort of cadence because it's really hard right now. That's almost it. I'm supporting Danielle a little bit on the hemp stuff, and I've done a new issue that's writing up the remaining roadmap to getting self-hosting codegen, doing codegen of the types that describe schemas so that we can use those types to drive codegen. That's a decently long road, but I think I broke down all the steps in an issue now, so that's the first step to getting started. That's about it.
Thanks. Next one is Rod.
Excuse me. Oh man, I'll be glad when this moves by an hour. I think that's next week. I'm ending daylight saving, so yay. Okay, I said last week I was going to escape DAG PB land, and I completely did not escape DAG PB land. That's pretty much all I did last week, but I was deep in it. I feel like I have mastered it, but I won't be making any commitments, and I'm not going to be escaping it this week because there could be some tidy up to do. So I went deeper into the decoding and identified 3 separate ways that you can vary the bytes and still get valid DAG PB, and you can represent the same data in different forms. And these combined could give you infinite variation because of the way that they stack up. And this is because PB is really designed for protocols. It's not designed for content addressing, like everything else we do. This connects to stuff that Michael's been talking about too. It's just like a convenient way of representing things in binary, not a way of doing it consistently or canonically. So in PB, the decoders will accept out of order fields, even though the PB schema tells you the order. They just accept whatever order that they come in, and will build it up however you like. They'll also accept repeated fields. So if it receives the same field with different bytes, it'll say, oh, okay, and just overwrite what it had before and not complain or anything. It's completely silent. And then it'll also accept extraneous bytes that are valid PB, but not valid for the schema that you've presented. So it'll just skip over them and say, hey, this looks like protocol buffs, but proto buffs, but I don't know what it is, and I'm going to ignore it. There is a nice mechanism in Go, the Go proto buff codegen stuff for collecting that stuff and attaching it to part of the struct, so you can validate that in Go at least. So I implemented the super strict decoder for JS, and it's in the JS DAGPB library. I'm still interested to see what it does with the real world data out there, because there's a lot of DAGPB in the wild. But you know, encoders are good. The encoders are all very good. They'll do what they're supposed to. It's just the decoders that are flexible. So unless there's a particularly bad encoder out there in the wild somewhere, this should be fine. But this implements a one-way, one-to-one. This is how it has to be on the way in and out. I revisited the spec PR again. I think that it's ready for landing as of yesterday. I wouldn't mind a couple of eyes, but otherwise, if I don't get any more reviews, I'm going to land it. I put in some more clarity about the schema and the constraints. And after Eric's input, which I thought was quite good, the links field is now not optional. It always must be there, even if it's empty. And the argument for that was because you can't differentiate between an empty links array and a missing links array in the binary format, making it optional introduces another state, the cardinality that you have to deal with, and there is some ergonomics there as a programmer that can be annoying, because then you as the person interacting with this object need to do the check. Does this thing exist? Okay, then I'll look in it. But if you make it not optional and make it always there, then you can take for granted that it exists and say, well, I don't need to check for it to exist. If this codec is implemented correctly, it will always be there. And so that's in the spec now, and that's in the codec, the JS codec anyway. So when you construct one of these things, you always must have that array. And when they come out of binary form and they decode, it's always there. So it's just always there. And this prepare method in JavaScript is there to help you with that as well. So you don't have to throw these links arrays at it manually if you have a use case where that doesn't make sense, which is a lot of places. Like making an empty array is not something you normally do. And then I put some additional notes in the spec for around strictness of decoding. So these things that I detailed above, I wrote them into the spec and saying that these are shoulds. They're not musts, but they're shoulds. And they're not must because it's like this is not how you normally deal with protobuf. You don't normally write your own decoder. But if you're in a position to do so, then you should make sure it strictly does these things. And we've got that in JavaScript now. And I did a Go version as well. So there's a Go DagPB repo in my GitHub that mirrors the JavaScript one, and it has all the strictness in the decoding. It has the everything cleanly in the encoder, and it also tries to deal with this data model representation side as well, where the thing you give it must be of the right shape. This is just the low-level portion of it. It's like a drop-in replacement for Go Merkle Dag, at least the protobuf version of protobuf portion of Go Merkle Dag. So it could drop into IPLD Prime Proto, or we could make a new IPLD Prime Proto that has this stuff. And I'm interested in. It's still fuzzy to me what the builder interface is when you have a custom codec in IPLD Prime. And Hannah never fleshed that out with IPLD Prime Proto, because that use case was more about pulling the data out to use selectors over it. And so I don't really know what it looks like when you've got a codec that is very strict about the forms that it accepts, what your builders end up looking like, how you export assemblers from that thing. That is completely fuzzy to me, and I wouldn't mind understanding that, because this same thing comes up with all of the other codecs that we haven't implemented, like Bitcoin and Git and all the rest of these things, where the shapes have to be particular. You can't just freeform build these dynamic things. No, you can only build them in this very narrow way. What does that look like in IPLD Prime? I would love to know. Not necessarily because I want to implement something, but I keep on hearing that when I look at this code, and maybe I should try and implement that. But I'm not going to hold myself to that. But that could be somewhere where I go this week just to have a look. And the other thing was I gave a talk at the end of the week at Speakeasy.js about, it was titled Content Address Data Structures. And I decided to back right up to the beginning, because there was a bunch of talks, including Michael's, at Speakeasy.js that just went straight into content addressability and even the guys doing Hypercore and what's the browser? Beaker browser. these guys just don't jump straight into content addressability and data structures, and let's talk about B trees, and let's, you know, do distributed data structures. And it's like, I feel sorry for the audience, because mostly this stuff is not that well socialized in our industry. It's sort of, we're a little bit fringe still, even though this is straightforward when you delve into it. So my talk was aimed at the beginner level stuff, and so I covered content addressing, hashing, and then just move really quickly into how do we use this to build just data structures that have this superpower of linking. So I'm not super happy with how the talk actually went, mainly because I was really tired. But I was going to extract that talk from that thing and put it up as a separate video. And I have the slides of that if anyone wants to take them and use them and improve on them. I wouldn't mind trying to improve on this myself if I have opportunities to iterate on it. But I thought the sequence worked out quite well. And that's me.
Thanks. Next is Chris.
Hey, so it's interesting, Ron. I'm glad that you posted that video. I wanted to come listen to your presentation, but I had COVID at that time. But I guess I'll lead with my last thing on yours. I've been evangelizing the heck out of IPLD and content addressable storage in the healthcare medical imaging community. And it's tough. I mean, you're right. I mean, this is still like very fringe things. And, you know, my challenge is to try to figure out how to communicate this in a way that, you know, leads them, because there's no way you can go in an hour and like do a brain dump on someone. They just like get it, unless you're like super genius material, you know, it's just time. But I am making good success. And I have just so you guys are curious, like got some really strong interest from like people at Microsoft and other like major health systems like Kaiser Permanente. I don't know if maybe in the European, you don't know who they are, but some pretty big players that think this is like a good idea. So it'll take a while, but I have been doing that, and to good success so far. In terms of my day job, I did finally begin working again last week, and so working on a JS GraphSync spike, and it was frustratingly slow progress. Just trying to figure out the P2P stuff, and I think it was really hindered by my lack of Go fluency, and the library, you know, all the libraries are there, so I can read Go code, but I can't necessarily find the code I'm looking for sometimes, amongst everything else. But at the end of last week, I did actually successfully get a JavaScript requester connecting to Go IPFS GraphSync, yay, and a responder connecting to Go IPFS GraphSync get test app, and then them talking to each other. So at least I have kind of like the basic libp2p connection things working. And just for those, you know, why was that so difficult? Because it really shouldn't have been. Well, libp2p decided to change the default encryption provider from SecIO to Noise, and I just didn't know this, and so I was getting all sorts of weird encryption errors I wasn't expecting, because like one thing was using an older version with the original SecIO default, and then my code was using the newer one with the Noise default or something like that. And then also there was a undocumented thing in GraphSync spec about framing of the actual messages. So apparently it prefixes the size of the message with the varant in the stream. And so I filed an issue on that. I'm going to update that, or I'll update the spec repo with this and other changes I find. I think the GraphSync spec could use a little bit of love as it's written right now. So I'll do, I wouldn't say an overhaul, but I'll do a bigger update later on. Currently working through, so I'm not quite out of the weeds on libp2p right now. There's some kind of weird streaming issue that using IT pipe and family that I spoke with Michael about, and have a new strategy to deal with that. And I'm also planning to use your new DAG PB library, Rod. So I just know that is coming, but I'm sure everything will just work first time. And I'm hoping to get the spike done early this week, like either tomorrow or maybe Wednesday. And I'm going to start refactoring that code into library, do some kind of quick integration with JS IPFS to allow the browser extension guys to like go forward, and then finish the rest of the functionality following that. So that is my update.
Thanks. Next is Michael.
Yeah. So new doc site is up. The main website URL is now redirecting to it, so that's all done. I worked with Gozala to land his big JS multi-formats refactor. That actually went pretty well. God, the API is really nice. It looks really nice. The implementation is not how I would have done it, but like, you know, I think it's a lot nicer for TypeScript people. So whatever. Walker likes that. And yeah, so that was that. The main thing that I want to talk about, and Rod kind of hinted at this, is just the situation with formats, like our codecs and the formats in general. Conversations with Rod and a few other people last week, particularly the one with Raul. In libp2p, they just want to send some messages, but they are signing those messages, and they may hash them at some point. And so, even though they're not putting links in them and they don't need DAG features like IPLD usually provides, they're going to end up with a lot of the same kind of hash consistency concerns that we have. And in trying to advocate like what should they do, it was very clear that like we don't have the thing they would want to use, and we need like a much simpler format for them to use for some simple case like this. And so here's my thinking, and I'll just kind of brain it to some people and they can tell me what they think. But as we look at how these are actually being implemented and adopted, the way that we adopt and use this technology is just not the way that most consumers use it. We're trying to create libraries and data structures and a blockchain for storage and a network for storage that is like agnostic of what people are doing and how they produce the data. So we live in this world where we have to create the stack where all of these different choices are options. And we end up with like, you know, we're getting to the point where we have really nice abstractions for working with all of this stuff. But in practice, most applications are working with one type of data with all these choices as constants, not as variables. And it's just significantly simpler for them to basically implement the protocols just in line. And if you look at a lot of our protocols, they're really nice and they're getting adopted this way because they're so simple. And we've actually like learned just not to worry about them doing this, right? Like a lot of people, you know, produce multi-format stuff and they just sort of, they just stick buffers together and stick binary bits together and prefix things and like, hey, it works and it's really obvious and like we're not worried about them messing that up or writing bad data. And as we see the codecs get adopted, like if you look through Filecoin and like how Filecoin is adopting it, and like we just heard about a bunch of extra things in Filecoin, a bunch of extra things in DAGPB that like, you can do and that people are doing in the wild, where they have these one-off implementations where they're moving outside of the data model. They're not like they're not picking up all the hash guarantees that we have in DAG-CBOR. They're not really producing DAG-CBOR data, frankly. That's just like not what's happening with multi-formats, and it's not how you would really want to design a resilient protocol. If you kind of unwind everything, we've been coming at this from the point of view of like, it would be better to build on an existing format and then not really inspecting why that might be. And normally the reason why you want to work with an existing format is that there's a bunch of libraries already and a bunch of people already know about it, and there's a bunch of mind share. And so you get to bootstrap on top of that ecosystem and not write a new format. But since our number one concern are these hash consistent round trips, that jumps to the top of our stack, and we don't want to make any other trade-offs for that. And so the way that we implement that on an existing format is a library. So we're not really writing a protocol. Like I really don't feel like the way that it's being adopted and the way that we're asking people to adopt like DAG-CBOR is a protocol. It's like a library. Like we wrote a bunch of libraries that we need people to use because it's really easy to fuck this up. And so like, don't write it yourself. Don't write a partial implementation of just the things that you need. Like if you need to serialize just a list of integers, I'm sorry, you need to take this whole library to do that. And that's not going to be resilient to the ecosystem that we're trying to build. Like we should expect that people are going to keep doing what they've been doing so far and doing partial implementations and one-off implementations. And what we probably need actually is a format that's resilient to that, not one where there's an existing ecosystem that we thought would be a benefit, but is actually our number one problem. Because when people just grab CBOR libraries and do things with them, they tend to write bad data because we literally need them to not do that. So anyway, in an afternoon, I wrote a really simple format. And I'm glad that it didn't take very long, because it should be really simple to implement, because then that means that people won't fuck it up. And it looks a lot like multi-formats for the IPLD data model. There's just sort of, typing prefixes in front of data. And that's just, it's just turtles all the way down in terms of the collections. And I've been working with Volker now on what to do about floats. There's still like a lot of questions there, and there's going to be some more documents and stuff, and we'll work that out. But one of the things here is that I want to get the implementation fully tested in JavaScript and get Volker happy with it and what the Rust implementation might look like. And then I want everyone else to look at it and consider implementing it, just so that we can make sure that it actually is really easy to implement, that it is really resilient to implement, especially partially implement, so that we can still design to that. And what I really want to have is just like I want us to be able to point in a DAG format and say, if you're doing a simple encoding, here's what you should use. And if you're just serializing a list of integers, you can just serialize a list of integers and just implement that. And it's a really simple path to write that, and you're not going to mess it up. And I think that that's going to just get us out of a lot of the problems that we're having on top of our existing formats. Especially since in this format in particular, we're kind of trading a little bit of the compactness of CBOR for just ease of implementation, and resiliency to different implementations and partial implementations in particular. ZDAG, like, I love it, and I'm going to keep working on it for probably a number of years before it'll be usable. But it is like not resilient to partial implementations. There's a million little compression algorithms that you have to implement. But yeah, I mean, this is like kind of a big departure from where we've been going, which is like DAG CBOR, DAG CBOR, DAG CBOR. And to be clear, like, we can't get rid of it. Like, the Filecoin chain is in it. In IPLD, we have to support things as long as people link to them. So we're going to be dealing with it and the problems forever. But we at least need to have something we can point at and say, like this is the right path, and this is making the trade-offs that we think are like actually the right ones. And for some of the stuff like Volker's building around the WASM read-only codecs, like, he needs an intermediary binary format to move the data model back and forth. And implementing all of DAG CBOR is probably like much less attractive for that interchange format than something like this, where it would be a lot easier to implement in different host languages for these read-only WASM codecs. So yeah, if people have a chance, they can check out the spec, or just wait until Volker and I finish up the float stuff. But yeah, I mean, thoughts and comments and
So I've been thinking about this quite a bit with my work in the DID specification, and in particular, like the challenges of converting from CBOR to JSON, and not just DAG CBOR, but CBOR, and how do you just, I think numbers and date timestamp is actually like really hard to do. And so I've recently actually, for this, I have a deliverable for tonight to get, like I mentioned last week, to get the CBOR specification for DIDs into the specification. Otherwise, it's being threatened to pull it. And I'm actually using CDDL. Not sure if you guys are familiar with concise data definition language, and it also is basically, it really is an abstract data model. And it really is like more of an interface data language than it is a library, and where you explicitly state the abstract structure of the data, and as either objects or maps or numbers or floats. And also in CBOR, there's actually quite a bit of tags to let you know like what encoding this should transfer into. If it's basically binary, but it's prepended with a tag 21 or 23, it's supposed to basically convert into a JSON object being hexadecimal. And so I feel your pain, and I think it's but I'm really liking CDDL as being explicitly as possible in order to make sure the ease of conversion between CBOR and JSON is backwards compatible. It's completely round tripping. And I've been doing a lot of testing all weekend actually to make sure that all the stuff we have in the specification, it's mostly JSON centric because they want it to be readable, but a lot of the Seaboard stuff isn't very readable. It's machine processable. And but using this abstract languaging approach, basically it's a structure, and it basically it is this in CBOR, it's this in JSON. It doesn't matter as long as you explicitly state it in CDDL, and everything from maps, arrays to it's very expressive, and even allows a lot of regular expressions for timestamp information, for instance. And I had to brush up on my skills of regular expressions in order to get it to fully work. But it would be interesting to actually have a multi-codec for CDDL, which is basically the explicit abstract data model as basically like an embedded, almost like an at context for JSON, but basically like at CDDL that allows you to say, and this is the structure explicitly of this object of things that are actually in it. And here's where it could be binary. Here's where how many array members in an array it could have. Here's the either regular expressions and even tag information. You actually can put in that this needs to be, this data has to be in binary, prepended with a tag 23 for hexadecimal, and it's completely binary as far as the representation of the semantics and the structure and the syntax.
I can see how CDDL would be really nice in a spec. But I'm just, in terms of like using existing formats for these content addressing cases, like unless that format happened to, and I haven't seen the format do this yet, but unless the format happened to say, okay, hash consistent representations are the most important thing, and we have not made any trade-offs in the other direction. Like it's hard for me to see how we end up not being in the same situation no matter what the format is, where we're not really describing a protocol as much as we are saying you have to use this library. You know what I mean?
Well, I think this is in between, which is it's not a fully fledged library. It is very concise interface declaration of the objects that you're dealing with. And I think without it being like the full, like again, like you basically like in CBOR, you prepend it with a tag, and it basically it hints at as far as what the expanded string interpretation and interpolation might be in other languages, other representation, other core representation models.
I feel like the point, though, with all of these specs, it's this catch-up thing that we're doing where we add on, with this spec plus content addressing, and it's always that additional bit where it just breaks down because none of these things are designed for that. None of these spec processes care about content addressing and consistency in that. And so when we tack it on the end, we're the ones that are accepting compromise. And there's always these compromises involved, and there's nothing we can do about it because we're not connected to the spec process, and the spec process doesn't care about our use case yet. So we're sort of trapped when it comes to interacting with any of these specs.
I don't think that we really understood how important prioritizing that hash consistency was until later on, after we had already kind of wrangled on top of these formats. Like it's not like a trade, like we can't really make trade-offs in the other direction, even when we're just mapping stuff on top of a format. It's like if you have all these ways in which you can still get out of it, then it's not actually doing the job that we want it to do.
I'm still a little bit shocked at digging into protobuf just how bad it is at this, because DAG PB it's got literally two data types. That's all it cares about in the whole format when it comes to the binary representation. And it still can't do them consistently. And the spec is just, it just doesn't care about it. It just doesn't care about this case. And so
No. It cares about the opposite thing. Like it really values the flexibility of the format. Like the fact that you can extend it and continue to add things to it later without breaking the old schema is a feature, not a bug. Like they actually designed in the other direction from us.
But this is a format with schemas. This is a format with schemas built in. It's not like CBOR. You define a schema ahead and you put field orders and you define data types ahead of time, and yet it's still terrible for us. Yeah. Anyway.
I have there's one agenda item on, but I don't know who added this item. So someone added selectors exposure in Lotus API danger of non-path incomplete selectors. Whoever added it, please.
I did.
Yep.
I did. Yeah, so I want to talk about this really quickly. It came up today. It was asked like, where are partial retrievals from Filecoin? To which Hannah jumped and like, well, I'm just going to add a CBOR representation of a selector into the API, and you can submit your entire selector like as is, and we'll just try to go with it. The problem with that is the following. When originally I was looking into how to implement all of this, it became pretty quickly clear that we need to only allow somebody to supply a path that terminates to a single thing. Because because the entire Filecoin transaction is essentially allowing for one and one selector only and nothing else. So you're asking the other side to send you something starting from one root. And this something, number one, is to be a complete graph, so you cannot like skip stuff in your selector. And additionally, the output of this subgraph also needs to be essentially one thing, because otherwise, like you retrieved it, and what do you do with it after that? It needs to be some sort of DAG or something like this, which you can just give back and say like, okay, you asked me for this sub path. I'm actually going to like take this path selector. I'm going to ask for this selector plus full recursion from the other side. They're going to give it to me. I'm going to run the selector again, find out where is the subroot that you asked for, and then I'm going to give this to you back, either as a car file or as direct output. Yes, Michael, go ahead.
No, well, that's not necessarily true. So like the use case that we have for paths and why we were looking at adding paths in was the Lotus retrieval command wasn't just give me these blocks. It was actually like, give me this file at this path. And so it definitely did need to be one whole thing that was just sent into one file that you would then output. But we have cases like what Chris is building now for JS GraphSync is going to hook up over an RPC interface to some Lotus client. And then that's going to be doing GraphSync requests, retrieval requests. And what's going to come out of that is actually the raw blocks from the retrieval request. So it's actually fine in that case if you give it a selector and you're selecting a bunch of stuff in various different files that don't necessarily like concatenate together or become one semantic representation. Like it can actually work with like the raw graph retrieval data from the selector.
Yeah, but it needs to be number one, it needs to be a full graph. Number two, yes, if it does stream out the blocks directly, that's fine. If it doesn't, then it goes into this entire trouble of we basically now have I'm trying to find the word. If I understand this correctly, we basically have a sub store per retrieval, which is then garbage collected when the retrieval ends. So you have this entire like, you need to basically keep holding the DAG before it goes away while you're retrieving it. And if the selector is not complete, then how do you even hold it?
So I said this like a half a dozen times during the design and implementation of this that it should not keep a buffer around. It needs to require deterministic ordering. And that just got ignored, and they kept this buffer around, and now we don't know if we actually have deterministic ordering between the client and server because nobody ever errors, and they keep the whole fucking thing around. So now we're in this position where it's like, oh yeah, we have to keep the entire retrieval around in order to do this. It's just anyway. Yeah, like that's just a bug. Like in my opinion, like it's just a bug. Like we just shouldn't allow indeterministic graph sync replies. Like if you give me the blocks out of order from what I'm expecting from my local interpretation of the selection, then I'm gonna give you an error. I'm gonna throw. And that's how we should solve the buffering issue. The other issue though is like I saw this fly by, but I think that I jumped a little too quickly to thinking that this was like connecting the retrieval protocol to something. The RPC interface for this and the CLI for this, do they concatenate like the raw data that comes back into a file automatically? Or do they have some mechanism to actually give you block data from the retrieval request?
The mechanism is you ask for a car file.
Okay. Okay, that's totally acceptable. And that sort of maybe solves some of the buffering stuff, but I'm not sure.
Yeah, I'm not even saying that what Hannah is proposing is wrong. I just want to like highlight that there are pitfalls in just allowing any kind of selector, because like GraphSync itself is not prepared for that.
I mean, so selectors have a bunch of issues that we should take more seriously, like potential DOS vectors. But in the file clone retrieval market, we don't need to be too worried about that because you have to pay for them. So it's not a great DOS vector if you have to pay money to exploit it. It's usually how you fix DOS vectors. So I can't think of anything to be worried about right now. Maybe Eric does though.
From my perspective, it's not that much about attacks. It's more about, well, you let me use this thing, but it doesn't work. Make it work for me now. And it like would not be able to work on a on an architectural level. So that's basically what my concern is, that we're exposing something that's super generic over something that's super specialized, which is being the GraphSync file clone retrieval. So that's basically why I'm like, are we sure we want to do this?
Well, the GraphSync stuff in the retrieval market is already pretty open-ended because it does allow you to give it any selector. So even if we didn't add this to Filecoin, like somebody could write a client and talk to the network and send them whatever the hell they want, right?
Yes, but nobody wants to do that for obvious reasons.
Yeah, but like, I mean, if like obviously like that's not ideal, but like if that's not ideal because it's really hard to write that, then it actually makes a lot of sense to add this feature into Lotus so that you can just give it whatever you would without writing a custom client. I mean, we're not blocking anything. We're actually just opening up in our client what is already available in the network and in the protocol.
Eric, do you have thoughts? No, because we were making different faces while we were talking about selectors over, so on and so forth. So I'm just checking that. So,
the things Michael said about like, yes, the traversal order should be entirely deterministic, and protocols should halt immediately and hard when things come in an unexpected order. This is true.
Yeah.
Cool. So yeah, no, I just want to surface stuff. Yeah.
Like the thing is that I've been down this road. Like I've played this game before, and there is no satisfactory answer for how large that buffer should be. So like the answer is to not do it and to know that you're stable, and that like the moment that somebody doesn't do this correctly, they get an error and they don't try to ship that code.
Is there a defined order to send blocks in GraphSync? Since we're kind of talking about this, right? I don't recall reading about that.
The order is defined as the order that the selectors yield them to you, and the order that selectors yield things to you is defined by the iteration order of the data. And the iteration order of the data is defined to be whatever the heck it is. Keep it stable.
It's the encoded order, which in some codecs we enforce and some we don't. But whatever was encoded, even if it was encoded bad, is what you should do.
Exactly. Yep.
All right. And so that means then that a graph sync responder, if as it's traversing the graph in the correct order, if one block gets hung up, it just stops the whole protocol. Is that correct?
Ideally, yes.
Is
Yeah,
sending
ideally.
a block over something else that multiplexes them in a random order?
Yeah, ideally, yes. Because like you have to realize that the problem, if you allow a small variation in order, that variation in order very quickly is now just a variation in link order, which means that like the subsequent selection of the subgraphs is out of order, which means that you have to buffer that entire subselection often in order to, unless you have like a concurrent selection validator, which is like nobody's written, then you very much like, then you have to buffer that around. So it's not like we can say like, oh no, keep a few blocks around. It's like, oh no, like this is going to very quickly turn into I'm buffering entire subdags of whatever length. And eventually that length gets too big when somebody has a bug, but nobody notices it until they have a really big graph that they're running over this bug, which is why no, fuck this, error right away when somebody does the wrong order so they know they have a bug and then we don't ship it.
Well, I mean, I hear all the rationale. The one thing I'd say is one of the things about graph sync is it's supposed to be like a high performance protocol where bit swap isn't, at least from peer to peer. So you have, requester or responder, like it's supposed to go really fast, where bit swap is limited. And so this could impact that, I would say, goal of graph sync in terms of limiting performance. Given the speed of the block store, you may be throttling things because you have some blocks, but you don't have other blocks yet. They're still coming out of store.
I mean, if you're saturating the network with what you've got from disk, then I'm impressed. But
some pretty fast
Seriously.
networks nowadays.
Yeah, and frankly, like it's not. I mean, look, it's not performant to buffer a ton of data in memory, like for an indefinite amount of time without you seeing it. Like, I don't, like that's the. I mean, yeah.
What do you think about it? Yeah, this is helpful information, especially since I'm implementing it.
Exactly.
But it's kind of surprising too, so I noodle on a bit more.
Well, and like
Go ahead.
if they continue down this and they ship it, then we're gonna have to like reproduce this bug everywhere else, just like we're gonna have to reproduce all these map bugs.
Yeah,
My understanding of, oh, go ahead, sorry.
If somebody wants to increase the throughput of these data pipelines, then like big picture, the point of selectors and how GraphSync is supposed to go fast is you request many blocks all at once in one query, and then you stream them back with this one question being answered, however many blocks it is, that is the answer. And so this does remove round trip times, right? You don't need a ton of acknowledgement to fly back. Like the sender can just keep streaming blocks back, and they should do that at whatever rate they can to saturate the pipe, and that's fine. And at some point, if the recipient of all of this response data starts getting things in totally the wrong order, I'm assuming we're using TCP, so this just shouldn't happen. If we're not using TCP, then something at the transport layer should be responsible for restitching this ordering as fast as possible, and like should take care of it before we worry about it at the protocol layer. And yeah, so then if the recipient starts getting these chunks streamed in totally incorrect order, then they should send a hard knack and like close this connection, because the far side is just not behaving correctly at all, and they appear to be trying to waste my memory, trying to make me hold on to stuff that I can't verify. I think trying to increase the throughput of this should pretty much just focus on trying to increase the throughput at the transport level. Like, I don't think there's any reason to allow whole blocks to be reassociated in radically different orders unless like, yeah, I don't see why that would be really necessary. Unless you're like, did somebody add an HTTPS 4000 or whatever version Google is up to now, where it like makes more connections and we're streaming whole different blocks on them for reasons, so it'll go faster? Like,
No, I think the thing I'm thinking about is supposed to be a graph that has some fairly large blocks and some very small blocks. And my responder basically realizes, oh, there's like 20 child blocks on this one. I'm going to issue async requests for all of them and start shipping them over as soon as they come back. And just so happens the first block in this kind of order is the big one. That means all the other like 19 blocks are super small. I can't send over yet until I read the big one. And so that's, you know, so I think that's kind of like a bummer in terms of performance. And then I think related to that is, you know,
but is this something that you're doing if you do not have yourself all of these blocks at all? Like you're doing sub requests on this person's behalf? And if so, should you be doing that? Because I don't know.
Let me say something. I think there is a disconnect. Chris seems to be under the idea that GraphSync is this super parallel protocol, whereas GraphSync is designed explicitly to be serial and to basically just walk the graph super efficiently, but not walk the graph in parallel efficiently at all. And in fact, Query are building something like that because GraphSync doesn't work for them and BitSwap doesn't work for them, but BitSwap is actually more performant than GraphSync as implemented and as designed.
Could be
yeah, if you have any cache state, like BitSwap can beat it just because you're asking for less things. You need less things. GraphSync isn't really designed for that. Like if you already have any of the blocks, like it's all your own manual work to figure that out. And then you're still doing a bunch of round trips for subqueries.
For that too, you can tell the GraphSync has a packet for like, tell me these hashes that I already have. Don't send me these.
Yeah, like the issue is that you don't. So you can't say here's everything in the block store, like that'd be too big. And you often don't know until you're traversing what are the relevant CIDs that you already had around.
Yeah, you can say subsections like building out from where you started, but then if you've got a layer that you don't know about, and then it happens that like the grandchildren of that you do have already, then you can't meaningfully declare that. This is true.
Yeah. And like I think that the way that we always imagine that people might do that is that they would just do multiple queries, like they would do the shallow, like you were talking about, they would do the shallow query and then a couple parallel queries and stuff. And then if you have them in the same GraphSync channel, you do get the deduplication of the blocks coming out. But yeah.
And in Filecoin you cannot do any of this because there is only one connection because it is predicated on payment, so you cannot do anything parallel.
Yeah. I mean, there's a lot of considerations here, and performance is not the top one in the retrieval market. I think GraphSync has other performance requirements for other use cases other than retrieval that make people want to make it faster, but retrievals are not going to be. Retrievals are going to be blocking on chain access. Like they're not going to be performance bound on these parallelism issues.
Peter, what's that other protocol you said that people like that they don't like BitSwap or GraphSync? Do you have a link to it?
No, I just know that they're working on it. Query.io, it's the company that Brandon is working at. They're like supposedly finishing it up and going to publish it. The way they move blocks between their shards of their, like, they have semi IPFS gateways.
I mean,
I don't know if they've done anything new, but to do a quick review of what I know they've done historically that they've been happy with. They made like a two-phase protocol where they would build manifests of all of the structure and size of the data and then send those around first and then stream all of the data later. And
that's exactly what I was just thinking we should do. Okay. Huh.
That works really well if you know the use case. It's hard to do generically. Like you just don't know how big that diff is going to be and where the information is.
It's like the thing where Windows file copies now, they give you the spinny progress bar for a while they say calculating size. But then after that, the progress bar is predictable and people like that.
Yeah.
Is it a little faster? Actually, no, it's almost guaranteed to be slower. But like various
User
attributes.
experience. Yeah.
Yep.
And there's, I mean, I have to think about this. I mean, actually, this ordering, I need to rethink about it for my use case. Something like this manifest or a streaming manifest with streaming blocks on top of it, maybe a better fit for what I need, but okay.
I think that we just need a lot more time with different use cases and protocols to understand what something generic would need to look like. Like I'm not really happy with like any of the replication protocols, to be honest. And I've even written a couple like different ones. And all of them work really well in particular use cases, but not generically. And the more that I dig into DagDB and like what you actually want to do when you replicate, it gets a little bit too complicated for something generic. Particularly when you get into like, I want to keep around parts of this graph by reference, but I don't actually want to move the data around. Like those kinds of decisions get like really, really difficult to embed in generic interfaces. But anyway,
Okay,
we're at time, so we should. Yeah, I need everybody who works for me to stick around because we have to do some planning at the end of the call.
Okay, then
okay,
good.
No, I got one more thing to tack on to the end.
Yeah.
Okay.
So this manifest discussion that we were just having, I think it would be really cool if we could extract some maybe mild convention or loose specification for that sort of thing. It seems to me like it would be totally reasonable to make some function which is roughly give me your block store and your starting hash and a selector, and I will apply this function and it will give me a manifest. I don't think we've specified that yet. It's something that you can pretty easily construct, but like, why not make it standard?
That would be interesting. That would be really interesting, yeah. Because you could just, then you could just modify the shape of it to match different use cases. Oh, that could be really interesting.
Yeah, and then we could start having like, maybe we can just even take whatever the query people have done and just be like, this is a standard now. They've probably done it approximately correctly, I assume.
Yeah. And I mean, it would probably end up driving some new selectors as well. Like we would identify some selectors that we don't have and some syntax that we don't have that you want when you do things like that.
Yeah, that's
all
it.
right. Thanks. So yeah, thank everyone and see you all next week. Bye.